This topic talks about the Lewis structures of ionic compound. But before that, let's quickly go over the formation process of an ionic compound. Because the Lewis structure of an ionic compound is the natural result of the process of ionic compound formation. To form an ionic compound, usually we need two elements. A metal that will donate electrons, remember metals are losers, and a nonmetal that can accept electrons, which means electrons will be transferred from a metal atom to a nonmetal atom. Once that happens, the atoms will become ions. They will become positive or negatively charged. The two ions will attract each other. Well, why do these atoms have to lose or gain electrons? Why couldn't they stay by themselves? That question has been answered in the earlier episodes. The why reason is that the octet rule, they want to become more stable. But today, we know that answer, but today we're going to look at a real world example to look at the process of the formation of an ionic compound to go over how the octet rule is governing the whole process. We're going to look at the case of sodium chloride. We're going to use sodium chloride as an example to go over the formation of an ionic compound. All right, let's imagine before sodium and chlorine meet with each other to form a compound that's called sodium chloride. Let's imagine there are two lonely atoms. One is called sodium, one is called chlorine. The two lonely atoms are floating around in the world, in the universe. This is the electron configuration of sodium. This is the electron configuration of a chlorine atom. The two atoms are floating around in the universe and they are not happy. Do we understand why they are not happy? Because they do not have 8 electrons in their outermost shell. They are not stable. So they are floating around and complaining, why don't I get 8? How can I get 8? Until one day, the two atoms come across each other. Now, once they see each other, they look at each other, I can tell you chlorine gets very, very excited. Why? We're going to see the reason quickly. So chlorine has 7 electrons in its outermost shell. It needs only one more to be 8. Now, the poor sodium just has 1 electron in its outermost shell. Well, nonmetals, chlorine in this case, nonmetal is mean, so chlorine is going to grab the electron, put it into its outermost shell, specifically into 3p subshell. Now let's look at what happens to the electron configuration after the electron is transferred. After the electron is transferred, sodium loses 1, will become sodium ion, Na+, positively charged. Chlorine will become negatively charged, chloride ions. This is their electron configurations. Sodium may not want to give up the electron, but it has to. Now the chlorine is right here, it's going to grab it. Electron is transferred. Now let's what happened. After this, there are 2 amazing things happened. Number 1, after sodium giving up 1 electron, the 3s is gone, shell number 2 now becomes the outermost shell. And look at that, look at how many electrons in the current outermost shell of sodium, 8. Suddenly, it becomes more stable. Okay, sometimes it happens in the real world all the time. Sometimes Giving up something could be a very rewarding process. By giving up an electron, chlorine, you want to take my electron, go ahead, I'm going to give up. Now I become more stable. That's the first amazing consequence of losing an electron. Now, number two, now after chlorine gains 1, chlorine feels very happy. Okay, I'm getting 8 now in my outermost shell. However, you become negatively charged. Sodium, I am positively charged. Now we attract each other now. Chlorine, wherever you go, I'm going to follow you. So they are bonded together after the electron transfer. Ever since from that moment, the two lived together forever. That's the process of the formation of sodium chloride. Now there's one question we didn't ask on the last slide. I don't know if you guys had that question when we were on the last slide. Why would a metal, sodium in this case, why would a metal lose electrons and non-metal gain electrons? Why wouldn't the metal gain electrons? The sodium, there are actually two different ways to satisfy the octet rule. Number one, by losing 1 electron, shell number 2 becomes outermost shell, 8 electrons. That's the one we just went over. But there's another way, actually, possibly. Sodium can gain 7 electrons, so that shell number 3 will get 8 electrons. Why wouldn't sodium do that? Well, let's look at the sodium. A sodium atom has 11 protons holding 11 electrons. Gaining 1 more electron, assume, let's consider this process. Gaining 1 more, it becomes 12 electrons. Now, do you feel that this 11 protons in the nucleus suddenly feels like they have more work to do? Before, the 11 protons are holding 11 electrons, now they are holding 12. Those electrons repel each other, remember that. So the 11 protons in the nucleus feel that, oh, it's kind of becoming harder to control all the electrons. Well, 1 more might be okay. Another one comes in, becomes 13 now. It becomes a bigger burden for the 11 protons. To hold a second extra electron is way more harder than holding the first extra one. I assume you can feel that way. You can understand that because electrons repel each other. They push each other. It's just impossible for 11 protons to hold 18 electrons. That's just a job impossible for the nucleus of the sodium to do. So instead of gaining 7, sodium will take the easier way, just lose 1 electron. For the same reason, if we understand the process discussed above for sodium, we will understand the process for chlorine in this case. To gain 1 is easy. Now 17 protons, gaining 1 electron will hold 18 electrons. It's harder than before, but not that hard. Not only that, even though it's kind of holding more, however, the 8 electrons in the outermost shell makes everything more stable. So it's rewarding. It gains 1. Lose 7 electrons. Let's consider this situation. Again, initially 17 holding 17 electrons, 17 protons, 17 electrons. Losing 1, suddenly 17 protons will be holding 16 electrons. Now, these 16 electrons are feeling more attraction from the nucleus than before. Before 17 protons holding 17 electrons. Now 17 protons are holding 16 electrons. So each electron is feeling more attraction from the nucleus than before. Makes sense to you? Well, taking a second one away will be way harder than taking the first one away from the chlorine atom. So you can imagine that each individual electron being taken away is becoming harder and harder. It just becomes close to impossible to take all 7 electrons away from the chlorine. So therefore, chlorine is going to gain 1. Sodium is going to lose 1. Metals are losers. Now it comes to our today's topic, Lewis structure. It is a combination of Lewis symbols that represent the transfer or sharing of electrons in chemical bonds. In this chapter, we focus on the transfer, losing or gaining. Sharing is the topic of next chapter. So again, let's look at the sodium chloride situation. Okay, there are 2 lonely atoms. One is called sodium, one is called chlorine, and this is their Lewis structure. When they meet with each other, 1 electron transfer from sodium to chlorine. Now sodium, the original electron in the outermost shell, is lost. Now sodium once becomes ion, you put a bracket outside the sodium and you don't put any electron dots around it because the original valence electron, only 1, is lost. Then you put a charge on the outside bracket. Chlorine, you still put a symbol inside the bracket. However, you place 8 electrons around it because originally it had 7, gain 1 more, got 8. Okay, you place 8 electrons around it, you put a charge outside the bracket. This is the Lewis structure of an ionic compound. Eventually, they form the formula of sodium chloride. This, again, is the Lewis structure of ionic compound. It shows you what happens to the original valence electrons to the elements that combine to form the compound. You are required to know how to write the Lewis structures of ionic compounds. So let's go over the process systematically and look at how we can write it. Now we have seen the Lewis structure of sodium chloride. Okay, let me put it here. That's Lewis structure of sodium chloride, what we went over on the last slide. Now we're going to go over the steps for writing Lewis structures of ionic compounds. Right now we focus on the ionic compounds that do not contain polyatomic ions, because with our current knowledge, we do not know how to write the Lewis structure of a polyatomic ion yet. Once we know that, we'll come back here to complete the Lewis structure for ionic compounds that contain polyatomic ions. Now we focus on the ones that with no polyatomic ions. Step number 1, the Lewis structure of ionic compounds always starts with a positive ion, ends with a negative ion. Oh, yep, that's exactly what we saw earlier on the last slide. Positive sodium first, negative chlorine later. Now, to write the Lewis structure of a positive ion, what you do, you put the elemental symbol in the bracket. Oh, that's what we did for sodium. Elemental symbol in bracket, and you put a charge on the upper right of the bracket. Oh, that's what we did. Easy. Positive ion is easy. Elemental symbol in the bracket. Don't forget a charge on the upper right. Negative ion, Lewis structures for negative ion, you put the elemental symbol, but also with 8 electron dots around it, and then in the bracket. Oh, yeah, chlorine symbol followed by 8 dots in the bracket, then charge on the upper right. Oh, I think we're following it. Not that bad. It's easy. Step number 2, when more than one is present for the same ion, list them out vertically, one below another. What is this one talking about? I don't know actually. So let's move on. Once we encounter this situation, we will come back. Draw the Lewis structures for these 3 compounds. Okay, let's move on. Let's draw the Lewis structure of calcium oxide. Positive first. Calcium oxide, which one is positive? Of course, calcium. Calcium is a metal, oxygen is a nonmetal. Metals are losers, are positive. Nonmetals will gain electrons. So, calcium first, the positive ion, put the elemental symbol in the bracket. Charge upper right. Charge, what is the charge for calcium? We know it's positive. Positive, how many then? Calcium is in column 2A. Column 2A metals will lose 2 electrons. So the charge will be 2 plus. Negative later, oxygen oxide, 8 electrons around it. In the bracket, charge outside. Oxygen is in column 6A. 6A needs 2 more electrons to be 8. So 2 negative. That is the Lewis symbol for calcium oxide. Next, potassium sulfide. Oh, wait a minute. We have 2 potassium ions. We know we need to put potassium ion first, but we have 2. How do we do that? Right here. When there's more than 1 is present for the same ion, potassium ion in this case, you list them out vertically. Okay, I'm going to write 2 potassium ions, one below another. Potassium ion is just elemental symbol in bracket. Charge outside, potassium is in column 1A. Column 1A loses 1 electron. Charge is 1 plus. Now sulfide. Sulfide is a nonmetal. 8 electrons around the nonmetal. Charge outside, it has to be 2 minus. If you have 2 plus, if you have plus here, sulfide has to be 2 negative. Or you can look at the position. You can look at the position of sulfide in periodic table. It is in column 6A. Again, 6A needs 2 more electrons, 2 negative. Okay, so that's the Lewis structure of potassium sulfide. Okay, I'll make it right. That's the Lewis structure of potassium sulfide. Next, barium chloride. Barium metal. Metal is positive first. Symbol in the bracket. Charge outside. Barium is column metal in column 2A, so 2 plus. Oh, we have 2 negative ions, 2 chloride ions, one below another. 8 electrons. Nonmetal, negative ion, always 8 electron dots around it. Charge outside. Chlorine is from column 7A, so 1 minus. Well, even if you don't know that, if you know barium is 2 plus, each chloride has to be 1 negative. That's the Lewis structure of barium chloride. Practice. Draw the Lewis structures of this. All right. Try to follow the procedures laid out on the last slide. Draw this. Pause the video. Draw them out by yourself. If you want to check the answer key, unpause the video. Look at the answer keys for the 3. Here is the answer keys. I hope you got them right. See you next time.